Yeah. It's ready.
Welcome everyone to this Nmrg meeting. We are looking for a scribe for Java. Anyone volunteering? Please. Can you have one scribe, please?
Help.
Anyone volunteering, please? It will be much easier to have the meeting with a scribe for Java. Okay, thank you. And someone for the minutes? Anyone volunteering to take minutes? Jefferson? Where are you? Yeah, okay, I'll take the minutes.
Okay.
Anyway. Okay, Ms. Honor, go ahead, please.
Okay, good morning. So this is the traditional note well. So everybody knows about it. And then this is the agenda. We are in the agenda bash. We'll have a set of presentations on very diverse topics. We're going to start with Anycast versus distributed OS by Moritz. And then we move on to one of the drafts that we have on Nmrg by Jefferson. Then Klaus, we're going to present a reference model for managing large-scale software-defined networks. Then we have a presentation by Michael about the ANIMA working group. And then Alex will talk about slice networking management. We'll talk about the SUPA policy-based management framework, which have connections with Nmrg. So in this last three presentations, we will have connections with other groups, as you can see. And then finally, we're going to try to discuss about the present and future of Nmrg itself. Okay. So going directly to Moritz Miller. Moritz, please. Oh, you can tell me, and then I move to the next one.
All right, great. All right, good morning. My name is Moritz Müller. I work for SIDN, which is the registry of .nl. Sorry for everyone who was at the IPG. I presented the thing at the IPG already on Sunday. This is joint work of the University of California, which also runs the B-root of the name service, and the University of Twente, which in the Netherlands. And we looked at an event in last November, at the DNS root service, and we tried to look whether we can draw some more general conclusions about how you react with an Anycast network when you get a lot of query load. Okay. So the 30th of November of 2015 was quite a bad day for the DNS root service. Here you see on the left side the different root server letters, and these are the measurements of RIPE Atlas probes who query the DNS root servers on a regular basis. And here you see in the red fields that many of these RIPE Atlas probes didn't reach the different root letters at a certain point in time. And we were wondering what happened there, what does this red actually mean, and maybe can we draw some more general conclusions about how Anycast reacts on stress and how we could handle stress better in this case. So we can do that because the root servers are one of the most well-known DNS Anycast deployments there are. And they consist of 13 different services called letters, and these 13 services have 561 different sites spread all over the world. And we're wondering, is this number of sites too many? Is it too few? And what happens under stress? This is a paper that my colleague is presenting today at the IMC conference as well. and we made a bunch of contributions. So we have a public evaluation of Anycast under stress. We have a public evaluation of different design options, and we also looked at different how the impact of collateral damage. This all happened before, but we try to make it public and more transparent. What we didn't want to do is bashing different root server operators, so we don't want to do that. And we wanted to discuss possible future defense strategies. So a quick primer into Anycast. So imagine you have the fictitious DNS root server letter X with 3 different sites. One site is in San Jose, one site is in Prague, and one site is in Sydney. So you are located somewhere in the US or in Mexico in this case, and what Anycast does, it kind of matches you to the site in San Jose. It should at least. Then you have a friend who sits in Europe and he should be matched in Prague, and you have another friend who is in New Zealand and he should be matched to the site in Sydney. And thereby Anycast divides the internet into different catchments, basically. What you can also see is that some of the sites have bigger squares, which in this case indicates that the site in Prague has a bigger capacity than other sites. So this means that they might be connected to a bigger link, or they might have more physical machines in the background. So what happens under stress? There are different scenarios. So first, imagine you get a bunch of query load at the site in San Jose. So a lot of attackers, for example, are matched to the site in San Jose, and because the attack is so big, it overwhelms the site in San Jose, and you will be sad because your traffic is lost. Imagine then you have the same number of queries also that reach Prague, but because the site in Prague is bigger, the site in Prague can handle these number of queries and can absorb the traffic. And what also the Anycast does, it can isolate certain sites from this attack. In this case, the site in Sydney is isolated from the attack and is not affected. So your friend in Sydney is happy. So from a management point of view, from an Anycast management point of view, what could you do? And you have different options. So the first option is you could leave the BGP routing as it is. You don't do anything, which means that the site in San Jose will act as a degregated absorber. It will take the traffic. You will get sad because your queries are lost, and your friends in Prague and your friend in New Zealand is happy. What you could do is also you could withdraw certain routes with the hope that some of the attack traffic is redirected to another site. In this case, some of the attack traffic should be redirected to the site in Prague, with the advantage because the site in Prague is bigger than the site in Sydney in San Jose, and should be able to handle this additional traffic, with the consequence that the site in San Jose is back online, your traffic comes through, the site in Prague is also able to manage the traffic, and the site in Sydney is still isolated. But what could also happen is that you withdraw the wrong routes, with the consequence that some of the traffic is then shifted from the site in San Jose to the site in Sydney, with the consequence that the site in Sydney is overwhelmed as well, which means then you are not happy, your friend in Sydney is not happy, only the guy in Prague is happy. But how could you decide what is the best strategy here? You don't know. It's very hard to say the number of attackers. You don't know where the attackers are located, how big the traffic is, and you don't know the effects of routing changes. And you don't fully control actually the routing changes as well. So it's very hard to make an informed choice. We saw some of this behavior at this event on the 30th of November last year, the root service as well. And we saw that based on a different kind of sources. So we use 3 different kind of openly available data sources. One is the web address probes that probe the different root letters every 4 minutes. At this time, only the A letter was not probed was 30 minutes. So we didn't have the granularity to actually dive into this better, but every other letter was queried every 4 minutes. And this also lets us see which kind of site a probe reached at what time. Then we use the RSEC-O2 reports in order to get information about the traffic load, and we use BGP-Mon in order to get information about the routing plane. As a summary of event, there were actually 2 events. I will focus on the event on the 30th, but they were very similar. 10 of the 13 letters were affected. so were attacked because some letters were apparently not attacked because they had some IP renumbering a couple of years ago, and that was not updated. And this estimated amount of queries was rather low. I mean, compared to the attacks we have seen this year, it's like nothing. But still, some letters had quite high loss. So some letters were not reached by probes anymore. But overall, the DNS was fine because real resolvers, for example, they react different than RIPE Atlas probes. RIPE Atlas probes keep on probing this one single site, this one single letter. But if a normal resolver doesn't reach this one letter, it just changes into another one. So overall, then DNS was fine. So let's look in how the different letters reacted. And we see some quite big differences. So we see here that some sites weren't apparently attacked. So we don't see an immediate impact for the root letters D, L, and M. And for A, yeah, we didn't have enough measurements, basically. We see that some sites have some query loss. So this means how many RIPE Atlas probes reached this site at a certain point in time. And we also see that some letters were affected quite heavily. For example, B, which was not anycast at this point in time, but also, yeah, G and H was quite under stress. We looked at two letters in particular to get a bit of better insight what was actually happening. So in this case, I want to look at the K letter. Thank you. And so what we here see is the a number of sites of K, which is like Amsterdam, London Heathrow, Frankfurt, and so on and so forth. They have more sites, but these are the sites which are reached by most RIPE Atlas probes. And what we see here on the right side is for each site, we have the number of probes that usually reach the site. And we can also see two dips in reachability during the 30th and the 1st of December. And we see also a small spike there as well, which we can't really explain. But was it because of the pipe stream maybe clogged of the site, or was it because they did some routing changes? And in order to do that, we looked at the different flips of the RIPE Atlas probes. And what we see here in this figure, which is a bit messy, but basically we see here the sites that were reached by 300 different kind of Atlas probes. And if the color is pink, they reached the site in Frankfurt. And if the color is yellow, they reached the site in London. And if the color is black, that means they didn't reach any site at all. And particularly down there, something interesting happened, and I want to zoom into that. And here we see that 4 different kind of behaviors of RIPE Atlas probes, and not RIPE Atlas probes, but the network. So we see on the top RIPE Atlas probes that were located in London Heathrow or reached London Heathrow, and during the attack they didn't reach anything, so they stayed in London Heathrow while it was down, and then after London Heathrow was back up, they continued probing the site in London Heathrow. Then we see here on the second from the top, we see probes that flipped to another site. In this case, they flipped to the site in Amsterdam, which is the blue color. And after London Heathrow was back up, they flipped back to the site in London Heathrow. These ones, the third, were also pretty down during the attack and flipped to another site, to different sites after London Heathrow was back online. And we have some probes that flipped to Amsterdam but stayed there at Amsterdam even though London Heathrow was back online later on. So some implications of these flips. It seems that some networks were not affected by routing changes. So they stayed at the site in London Heathrow, even though London Heathrow was down, which means they will suffer a query loss during this kind of event. Some ISPs will flip, so this means they will change to another site, but that doesn't necessarily mean that the reachability of the other site is better, because BGP doesn't know how the reachability of the site is. It just knows, okay, here's the better route to this, here's a better route to another site, but yeah, it doesn't know how the reachability there is. And whether this happens or not depends on many factors. So for example, the operators could take some measurements to withdraw some routes, or routes might be withdrawn because the BGP session is down. And also depends on implementation choices. So RIPE Atlas probes don't behave as normal resolvers, but have a specific behavior, but recursive resolvers would change sites on a different basis. So should you do active route changes during stress if you have an anycast network? If you don't do active route changes and you don't do any other countermeasurement, then you should expect query loss there. So what you could do is just build out the capacity of your sites and hope that this takes care of the future attacks, and this is actually what happens right now. You could do active route changes, and if you do active route changes, this only makes sense if your overall capacity is bigger than the attack, so that you can spread the attack over all the different sites. But in order to know that, you need to have better insight about the routing control and about the impact of your routing changes. And I had some comments at the IPT session that this is maybe something that you don't really want to have, because it's kind of unpredictable how the routing changes. You might have route flapping and the stuff that you don't really want to have. So routing changes, active routing changes, at least as a single countermeasurement, is definitely not the only solution. But at least in theory, this is like the only case how you could achieve 0% query loss. As a side note, I mentioned collateral damage. So I mentioned that the D route officially was not affected, but we still see some query loss at some of the sites of D, which means that probably they're co-located with some of the root servers, and this is why they also suffered a bit. The same goes for the .NL name servers, like our own name service, which we definitely not attack, but we still see some query loss there. So that means we also had some shared infrastructure probably with the root servers there as well, which you also have to take into account when you want to handle this kind of scenarios. So recommendation, we have to be a bit careful about that, but the current approach seems to be reasonable. In order to avoid collateral damage, you need a diversion, and on long term, I think if you want to do more educated route changes, then you will need more measurements and more research as well. I asked the questions, how many sites are needed actually? And this is a very hard question to answer because many things depend on it, but in general, we saw a correlation between the number of sites of a root letter and the reachability. So if a root letter had more sites, the overall reachability was better. But again, there are many factors who play a role there. Next slide, please. That is basically it. Yeah, you can see the paper here. The data is public. So if you want to have a look at this, and want to see what actually happened, you can download it here. Thank you.
There are some additional ones?
Yeah, there are some additional slides.
Backup slides?
Backup slides, yeah.
Okay, thanks. Questions?
This is Yoshiro Yonea. My question is, did you see the behavior of resolver side? Because the resolver changes the root server if they had a long delay from the response. So if resolver changes the root server from, for example, from K to M, then the resolver will not be affected so much. So did you see such resolver's behavior?
Because the RIPE Atlas probes they resolve the root servers, the root server IP addresses themselves. So they don't use an intermediate resolver in between. So we didn't see the resolver change behavior, but real resolvers would change. So this is also why the root server DNS was fine in overall, because yeah, if they don't reach the site anymore, they should change. But we didn't observe that.
In the previous slide, you mentioned that in the long term, additional research will be required. I was guessing what's the plan of your group in that regards?
I'm not part of this group, but I know the UC has a server test bed, I think, in order to gain more insights. I'm not sure. Yeah, I'm not 100% sure about the details there, but this is definitely something we have. Also, the University of Twente has a test bed there, and any class test bed to also more see how routing behaves and what happens if you withdraw one route. So they do some more research about that. I got a question also at the IPG about more the resolver behavior. This is something that at least we haven't planned, but this is definitely something very interesting and something very relevant, because this actually reflects better the behavior of the actual DNS.
Okay, thank you.
Thank you.
Our next speaker will be Jefferson for autonomic networking use case for distributed detection.
Good morning. My name is Jefferson, and I'm going to present the draft autonomic networking use case for distributed detection of SLA violations. And this is work from other members of the team, Lisandro Granville, Alexander Clem, and Alberto Gonzalez. Next slide. So this is the outline of the presentation, and I think that it's important to say that this outline is closely related with the both of ANIMA working group. So we are one of the use cases for autonomic networking. So the outline shows the parts of our draft that was some kind of template from the use case for that BOF. So I'm going to start with the introduction, then the problem statement. After that, I'm going to talk about benefits of an autonomic solution, then the intended user and administrator experience for the use of our solution, the analysis of the parameters and information involved, the comparison with current solutions for the same problem, related IETF work, and some security considerations. My presentation is going to be finished with some outlook about the draft and some general considerations. So, critical network services are expected to work considering some service level agreements, some SLAs, and in order to have these SLAs, it's widely known that it's important to, in some way, to measure these SLAs. In order to measure these SLAs, it's necessary to have a monitoring infrastructure. And this monitoring infrastructure needs some kind of monitoring coverage of the network in order to capture the SLA violations. In order to do that, we can use active or passive measurement mechanisms, and considering SLA violations, active measurement mechanisms have better accuracy and privacy than passive ones, and they are also able to detect monitoring problems, network performance problems in an end-to-end fashion. In the context of the IETF, the IPPM working group has been standardizing some measure mechanisms, and they have one-way mechanisms. So we can talk about the OWAMP, one-way active measurement protocol, and two-way mechanisms. And we can talk about the two-way active measurement protocol. And there is also a protocol from Cisco, the IPSLA, or Cisco Service Level Assurance Protocol, which is also described in an RFC, which is not a standard, but it's defined in a public way in the IPPM. But in any measurement mechanism which are used in a network, it's necessary to distribute measurement probes on the network in order to deliver the measurement sessions and to produce the network metrics. So, please, yeah, thanks. And in order to do that, you have to inject traffic on the network in order to deliver these traffics. So our problem is that in order to distribute, to have these measurement probes activated in a certain location in the network, and also when you need to inject the traffic, there are some resources, some computational and network resources which are necessary to do these measurement tasks. And the required resources are a function of the number of measured destinations or the measured flows in the network. So if you have a better monitoring coverage, you need more resources, and it's usually difficult to find the sweet spot in order to have adequate coverage of the network, and also using some how can I say, some not too much in terms of the resources in the network. Besides that, when you have to monitor all connections in the network, it's usually too difficult to do because you need a lot of resources, and also you need some fast reactions when you have changes in the dynamics of the traffic of the network in order to change the configuration of your probes to capture this new state of the network. So currently the best practice is to distribute the available measurement sessions and the probes and the traffic which is injected in the network, considering the human administrator expertise. And after that, you can also use some information from the traffic matrix in order to choose which are the best spots, the hot spots in the network to perform this measurement task. So when you have some changes in the traffic matrix, you have also to change the location and also the the flows which should be measured in the network. So it's too difficult and labor intensive to have this kind of reconfiguration every time has occurs an important modification in the traffic matrix of the network. It's inefficient considering fast changing network environments, such as cloud environments and also virtual environments. And also, we still have the maximum number of detections constrained by the number of available resources for the measurement probes. Next slide. So today, the network equipment vendors, they embed management software to control measure mechanisms, and this is usually done in order to avoid problems such as starvation or inefficient operation of the device because of the resources which are being used for the measure mechanisms. And there is also a lack of scalability using these kind of mechanisms. So the resources and also the expertise are not shared among the equipment in the network. So probably the one that could share this information is the human administrator, which, as I said before, is a constrained resource in an operator or this kind of organization. So the benefits of having an autonomic solution for this problem, it's to steer the process of defining the measurement probes and the measured flows in an automatic way. And the design goals for such a solution are that this solution should be efficient, reliable, secure, and that should minimize the human intervention. In order to have a solution like this, it's necessary to have algorithms, protocols, metrics, and technologies to build a complete solution for this problem. Also talking about the benefits of an autonomic solution, there are some features that can be highlighted considering this kind of solution. The first one is that an optimization of the resource consumption and avoidance of resource starvation on the network devices. And this feature can bring some better efficiency in the measurement session activation decisions. And also it's possible to share measurement results. So this is part of my work as a PhD candidate, and we have some papers showing that it's possible to do that considering some constraints. After that, we also expect an increase on the number of detected SLA violations. So this means a better network coverage, and this in terms of the locations in the network, and also in terms of timing coverage. So you can have different flows measured considering different timing in the network. Besides that, it's also expected in an autonomic solution and a decrease of the time necessary to detect SLA violations, and this is because of the adaptivity of having an algorithm to reconfigure the probes and not to wait for a human administrator to do that in a network. And also we expect a reduction on the workload of human administrators. So at least we expect that it can avoid that the human administrator needs to reconfigure the network considering all the changes in the traffic matrix. Considering the intent, user, and administration experience, as I said before, an autonomic solution should avoid the need for a high expertise from the human administrator in the reconfiguration of the probes, and this can lead to have this kind of monitoring task in a network performed by less experienced human administrators. Also, some information still will be needed from the human administration. For example, the service level objectives regarding the SLA, which is being monitored in a network. So this is information that is still needed from the human administrator. And also, we expect that the configuration and the bootstrapping of network devices for the measured process can be performed by the algorithm, the autonomic algorithm. So it's necessary some information about the address of a solution-enabled device, a solution which is already been in the overlay of the measurement task. And also after that, after knowing one device in this device in the solution, it's possible to share the information for the configuration from this device. So we expect some exchange of configuration data among the devices themselves. And as I'm explaining the solution in an abstract way, but we have some results and some software considering each of these points. So we also performed an analysis of the parameters and information involved. So first, it's necessary to have some device-based self-knowledge and decision as an autonomic solution. For example, each device can need to store the SLO, the historical measurement, considering our approach, and also the decision on how to, on each location the network and flow which needs to be measured can be performed in a distributed way considering the network. There are some solutions that consider centralized and control, for example, using an SDN controller. But in this case, we suppose that it's better to have a distributed approach for this task. Also, we consider the interaction with different devices in the network, and the devices should and can share information about the network itself, for example, about the topology of the network and the flows which are interesting to be measured in the network. So in order to have this sharing, it's important to assure that the devices which are communicating have some, for example, some properties which enable the sharing of information among them. For example, the operating system or the neighbors or the AES features and this kind of stuff. And after that, considering this information, it's possible to create an overlay, especially for the perform of measurement tasks. There are different approaches for topology definition. So in my PhD thesis, we work with peer-to-peer approach to do that. So we call that the correlated peers, and we consider as a bootstrap information to initiate the overlay, the known endpoints neighbors as the initial seed. But there are other ways to do that. There are some works which consider a different kind of a decentralized autonomic infrastructure. For example, considering an event service communication plane, and there are other words that consider a centralized plane, considering just signaling information to initiate the devices. So considering other solution, there's no standardized solution for the distributed autonomic detection of SLA violations. And the current solutions consider or a per node solution, or also some ad hoc scripts running in the devices. There are some proposals that considering just passive measurement mechanisms such as DCON and CSAMP, and they don't have a focus on the autonomic features on network, for example, to avoid the intervention from human administrators. There's other solutions that are just that consider just some part of the problem. For example, considering the anomalies and the flows and the measurement just for this kind of anomalies. And we also described our solution, which considers peer-to-peer technology embedded in the devices themselves in order to build the measurement overlay, and after that to start to share information about the measured locations. Next slide. Okay, so considering the related IETF work, there are some parts of the problem state and also the solution that are related to different working groups. For example, we can see the LMAP group, which probably an autonomic solution for the configuration of this kind of probes would be an interesting feature, especially considering screening. For example, if you have to define which are the locations in the network that are probably can violate the SLA, so and a solution that could start this measurement process and to try to define at a high level which are the which are the locations which should be measured. This can be an interesting feature. We also have some relation with the IPFix, which is already been closed, but an autonomic solution for active measurement probably should be also performed and considered for passive mechanisms. For example, using flow information for the decision itself. As I said, in the best practice, a way to perform the configuration is using information from the traffic matrix, and probably this traffic matrix was known from IPFix or NetFlow, the OS flow, this kind of mechanism. Finally, we also consider some relation with the auto working group, because we consider an overlay for the measurement process, and we can do that. We can build a solution that considering some standardized way to build the overlay, for example, using the documents from the auto working group. Also considering all the items from an RFC, we also researched some security considerations, security problems considering this kind of solution. And there are some problems related to bootstrapping, and there are different groups which are working on that. We can talk about the Anima, the HomeNet, and other groups which are trying to have an integrated solution for bootstrapping new devices in an overlay, for example, for an autonomic process or for measurements or for other stuff. Also, it's important to have a secure way to exchange information in the overlay among the devices. So probably it's necessary to have some kind of signed messages or encryption in the information, because the information from the measure mechanisms, and especially from active measurement mechanisms, is sensible one, and it can be used as a pre-attack process, or even to enable some attack on privacy. And we also highlight some possible attacks for this autonomic solution, which are denial of service attacks, considering, for example, that you can make that some devices in the network start to have a lot of measurement probes, and this can lead to an starvation on the device or a problem in the performance of the device. And also, some results could be forged by a device or by a device which is an attacker in the network, and this can lead to measuring some locations of the network which are not important at some time, and then start to have, for example, an attack in another part of the network. So there are this kind of attacks that are possible considering this kind of autonomic solution. Next slide. So we are, as I said before, this was one of the use cases for the BOF of Anima, for the use case for autonomic networking, and how can I say, this kind of work currently is not in the charter of Anima, so we continued working on the Nmrg. Considering this draft, we presented, I think, twice or 3 times this draft. We have some information in the presentations about some changes and some modifications in the draft. We also have some direct messages considering members of the Nmrg list. And we are in the 4th revision, which are just minor revisions and the updates of the reference. Considering the outlook for the draft, we just see minor revisions, so the draft is pretty much stable at this point, considering all the comments we had before. And we also want to add as a new approach to bootstrapping a device, the approach which is being described in Anima working group. So we think that we are in the timing for the working group last call, and you are asking that for the chairs. And that is it.
Thank you. Questions?
Congratulations for this very good
Thank you.
presentation, but also for the paper. I have 2 questions, one a clarification question and one maybe a real question. I do understand and I appreciate that you put a lot of emphasis on monitoring probes. At the network level, suddenly you collect a lot of information, and it's quite a job to transport that information to a place where SLA model is and calculated, and the violations are calculated and then put back. So the question is how you dealt with the transporting the monitored information in a network, and is it something which you took into account or not? That's one question. The second, it appears to me that you apply this very interesting technique to SLA violation where actually you mean only monitoring traffic. However, a number of services are not necessarily directly linked with the traffic.
You mean like other network metrics like latency,
other things, for example, based on service models which exist today, there are other issues which need to be at account, which means I basically have to create probes, or at least to customize probes for specific type of services. And I was wondering if the work which you are doing will extend to this level of SLAs, different type of services. That's the second question.
Okay, thank you for the questions. For the first one question, talking about my approach, not because the draft is the description of different approaches to bring a solution for this problem. But considering our work, as we are based on a peer-to-peer infrastructure, we have the scalability for exchanging the information in the network. So this is not our main focus of the research, because we're more interested in having an intelligent behavior from the probes. But using a peer-to-peer approach, we have a better scalability considering the exchange of information. It's widely known that when you have a centralized point in the network to have all the information from the measurement process, as you said before, it's kind of a bottleneck for the delivery of network metrics, and we are aware of this, and this is one of the drives for work. So I think that we are in a pretty good shape considering this kind of requirement. Considering your second question, I think it's a very interesting question, and it's a very important question, and I think that in the last IPPM working group meeting, there are some works which are trying to, how can I say, to model a way to monitor service metrics. And I think that probably this work can be extended to consider when you have a defined, because we used some network metrics such as delay and jitter and this kind of stuff. But I think that if you have a defined metric for a service application, or even for different kind of network metrics which we did not consider in our work, probably it would be extendable to this kind of stuff. So I think it's a very interesting point, and it can be extended, but we did not do that. So it's probable. to do that.
Okay, thanks. We're gonna return to this work in the last presentation because this is one of the two internet drafts that we have active in the Nmrg today. So we have to take decisions on them, and so we're gonna return up on that again. Sure.
Jefferson, you mentioned that one of the goals of this autonomic solution approach is to also lower the expertise required from the human operator. But since we have a more advanced mechanism, what will be the kind of expertise or skills needed in order to configure in the right way those solutions? Because you don't have to care about how you place the probe, etc. But then you have to care, if I want to have an efficient mechanism, what do I need to inject to him? The intent or this aspect of configuring the system. Do you have thought about this? Or?
In fact, this idea and also some part of my PhD work was done in conjunto with Cisco. So two of our authors, one it was a former Cisco employee, and the other is still a Cisco employee, and we compare in Cisco the information which is necessary to configure an IP SLA probe and also to configure our prototype. And at that time, we had the idea that it's easier to configure our prototype than the IP SLA, but it's just, like it's not. How can I say? We did this as an informal evaluation, so it's not a formal evaluation considering, for example, a model of human interaction with the software itself. So I think that we can say, as an anecdote way, that we are pretty close to have the difficult to configure a probe, but I cannot say that considering a formal evaluation, which can be, for example, a future work for our solution.
Relay from the Jabber room from Alexander Clem. A configuration of the system will involve a few points. What is the likelihood with which SLA violations will be detected? Autonomic system determines how much probing to do.
Well, one of the points that probably Alex is trying to show is that we are just considering in our research work as single as SLOs that can be detected by a single device. So, for example, we assume that each device in the network can detect the SLA violation by itself without the help from other devices. But this is also some parts of the work that could be extended considering our work.
Okay, we need to go to the next presentation. Thanks, Jefferson.
We are going to the list for the working group last call.
At the end of the session, we have a status on
Okay.
research group draft, and we have a point for this.
Thank you.
One final addition, because he was typing. I was talking faster than he was typing. The configuration knobs are higher level. What's the accuracy objective? How much resources can you spend?
So, Klaus.
Our next speaker is Klaus Vermuth, a reference model for managing large-scale software-defined networks infrastructures.
Good morning. My name is Klaus. I'll talk about our ongoing work of representing SDN systems as multi-layer systems, multi-layer networks, actually. Okay. Well, first, SDNs are getting every time more complex. They're getting bigger, larger. You have more complex structure appearing, such as multiple controllers, hierarchical controllers, or distributed. You can have more complex data planes as the structure grows. Also, you can get more complex iterations between applications themselves and management systems that use those data provided by applications. Further, STS are intrinsically multi-layered systems. From the basic definition, we start with 3 layers at least: applications, control, and data layers. And with the system getting more complex, these layers can be actually subdivided in increasing number of sublayers or layers on their self. It's the difference is not much relevant. These additional layers may also be necessary in some deployments where you have other things complementary to the SDN system as well, such as NFVs. So you could have additional layers because of that. This scenario as a whole led us to the idea that would be interesting to have a model capable of represent such a complex system, but using a single and whole mathematical object to do this representation, pretty much as we do with a network that can be represented usually with a graph structure. We do this taking common basis previous work of ours, which is the multi-aspect graphs, which are structures that are capable of representing things more complex as a simple network. In this structure, aspects are sets that represent different features, independent features of the systems. For instance, vertices, the set of vertices is an aspect. Sets of layers can be regarded as aspects. Sets of time instants can be regarded as aspects. And doing so, we can represent systems that are networks, but are multi-layered and are time variant. You have multiple time instants, multiple layers, multiple vertices. And we can represent these as a single mathematical object. In this system, the edges will be represented as tuples, always even tuples, always carrying 2 elements of each aspect. Further, one important feature of this object is that it is actually equivalent to a directed graph. And this makes the usage of it very convenient, because everything that's already known from graph theory and graph algorithms can either be easily applied or directly applied to such an object. And also as a result of this equivalency, the representation of such an object can be done in the same way as we do for graphs, for instance with matrices like adjacency matrix. And the algorithms themselves are really very close resembling directed graphs algorithms. We have here 2 papers. The first one on multi-aspect graphs is a more theoretical paper in which we define this object and prove the basic properties. The most important one is the equivalence, or the way we put it, isomorphism of the multi-aspect graph and a directed graph. And the second paper shows how to make algebraic representations using usually matrices, and how to build algorithms for this environment of the multi-aspect graph. However, for representing SDNs in general, we only will need 2 aspects, namely the vertices and layers. So the multi-aspect graph itself would be too much elaborate to use in this environment. It's not necessary to have all that flexibility here. So we decided to define a special case of multi-aspect graph, which we call it the multi-layer graph, or MLG, which is capable of representing multi-layers. And here the representation has three sets: a set of vertices, V, a set of layers, L, and the edge set. Departing from the set of vertices and set of layers, it can be seen that the system can represent an arbitrary number of vertices and an arbitrary number of layers. So it's capable of representing the kind of systems we want to model here. Next, please. The edge of this MLG will always be a quadruple. And it actually is a subset of the Cartesian products of the vertices by the layers by the vertices by the layers. Here the V and L, which is the vertex set and the layer set. And here we have an example of an edge, which is V1, a vertex, LA is a layer, V2 is another vertex, and LB another layer. And as we mentioned, the edge has elements of each aspect shown twice. Next, please. And actually, what we do is to consider half of the edge as an object, here in blue, V1 and LA, and in red, V2 and LB. And we usually call these as origin and destination. And in this way, this edge can be actually seen as a pair of pairs. So the pair here, the origin and destination, will always represent a binary relation. In the end, we always have a set of ordered pairs. These ordered pairs are composite of pairs, but anyway, they are ordered pairs. And this is actually key to the characterization of this object as equivalent to a graph. Because every time you have this kind of binary relation, you can also represent this as a graph. This is not a formal proof, obviously, but gives an intuition of why this can be done. And of course, we can already see here that what will be the vertices of this object, which is equivalent to a graph, carries additional information. This vertex carries a vertex itself and a layer in this case. And this additional information can be used in algorithms. We will talk a bit about this later. Next, please. Here then, in this specific case, we can have three distinct kind of edges. We can have interlayer edges, only the layer changes. Here we have layer 0, vertex 0. Here we have layer 1, vertex 0. And the edge in red goes 0, layer 0, 0, layer 1. So the only transition was from layer 0 to layer 1. Next, in blue, we have the intralayer edges. These are edges that are more similar to the ones we have in regular graphs, because the layer never changes. So here we have in blue, in the same layer, layer 1, 1L1, 2L1, and 2L1, 1L1. This represents a bidirectional or undirected edge. And it's the same what we would do with a regular graph, where the edge would appear twice in the adjacency matrix, for instance. And finally, in green, we have the mixed edges, where both the vertex and the layer change. So here in green, we go from layer 0, vertex 2, to layer 1, vertex 1 in the green edge. So this is a way to see the distinct edge, which can help in the time of modeling the system in choosing which kind of edge is appropriate for each connection. And here, in a bit more detail, what we call composite vertices are. The composite vertices are actually the Cartesian product of the set of vertices and the set of layers. Here, for instance, in a small example, we have the set of vertices having 0 and 1, and the set of layers having L0, L1, and L2. So the set of composite vertices will have 3 elements, 0L0 to 1L2. It's just the Cartesian product of the vertices and layers. And these elements are which we call the what would be equivalent to the vertices in this object. So we call them U and V. And then, as we will see, the edges are always connecting two composite vertices. Here a small example of how this looks like as a whole. So we extended the example with the 6 composite vertices and put in a couple of layers just to exemplify a case. So we have here directed layers for intralayer, for interlayer, and here the mixed layers. So we can see here how they are characterized and how they can be used to build a graph based on this. And again, of course, this additional information that we have inside of each vertex can and will be used later in the building of algorithms, which can, for instance, express results only in terms of, for instance, vertices, while using the whole network to calculate this result. This, for instance, is a way to avoid one issue that occurs in traditional multi-layer systems, that when you aggregate the layers, you can create additional paths that originally didn't exist in the system. By doing it this way, we use the whole network, the whole system, to calculate the paths in the case, and the results will only reflect the paths that actually exist in the system, not the paths that are artifacts created by the aggregation process. Here just another small example, but it's a little bit different, and it will be the basis for the representation we will show next. So we just made a little bigger example so we can have more edges to consider. In the same way we would do in a directed graph, we can have paths going in this object. They will be defined by the same principles of antecessor and precessor that we use for directed graphs. And here we can see, for instance, there in L0, vertex 0 goes to vertex 3, so we have the edge 0L0, 3L0. 0L0 will be the antecessor of 3L0, or 3L0 is the successor of 0L0, the same as it would be in a directed graph. And we can construct a path in any way we desire, given that we have the necessary edges, same way as we will do it in a regular directed graph. Here we started at 0L0 and ended here at 1L2. So, next please. The same goes for minimum paths. And as we can see that this is actually a directed graph, the way of getting the minimum paths, the algorithms for getting the minimal path, is exactly the same as the one we use for directed graphs. In all cases, here we are showing the these graphs without weights, but as with directed graphs, we can apply waves here, and then we can have all the algorithms that are already known for shortest paths without waves, considering cycles, whatever. All those algorithms can be applied directly here, making the system very easy to use. So here's an example of an adjacency matrix for such a system. This adjacency matrix is based on a particularly chosen order for the rows and columns. Here we chose to have the vertices first, so 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and then the layers, layer 0, 1, and 2, and the same on the rows. So columns and rows, same ordination. By doing this kind of ordering, which we call as the canonical ordering, we construct the matrix in a way it's easy to interpret, to show, to see. Here in the diagonal, we have all the intra layer in blue. The reds are the interlayers, and the green are the mixed layers. Of course, as with all adjacency matrix, we could do computation of the positions, and it would represent the same thing. This way is only easier to visualize it, but it would be the same in any ordering. So now that we had a look in what the model looks like, we will show a small example of SDN-like construction, just to see how it would work. So here we have a very small system. We have 3 applications, 1 controller, and 5 data devices. And here we could connect everything in any way we wanted. But we choose the edges that make sense for the system. So we could have edges connecting applications. Of course, we have here mixed edges connecting applications to controllers, and also mixed edges connecting controllers to data equipments, and the network of flows here in blue. But further, if we had a more complex system, for instance, hierarchical or multiple controllers, we could split these controller layers in how many layers we liked. And we could connect the controllers respecting the hierarchy or the kind of classification we did to the split layers. The same goes to the data layer. We could also split this in multiple layers if it makes sense to model the system we wanted. Or the applications. We could classify different kind of applications and assign layers to them to make the system more easily to understand. And finally, what we really wanted to leave here is that this reference model we propose can represent SDNs with an arbitrary number of layers, if necessary. It is actually equivalent to a directed graph, making it easy to use, very convenient to use, different of other more traditional multi-layer representations. Can be represented by matrices and any other form of representation that suits a directed graph. So we are not restricted to matrices at all. We can use any other kind of representation. And we can use everything you already know from graph theory to apply to this, either directly, if we are considering only the composite vertices, or if we want to use the information that the vertices carry beyond only the connections, we do slight modifications to known algorithms in order to do that. The second paper we presented shows exactly how this can be done. And that's it.
Thank you. Questions?
Yeah, thank you for the presentation. I have a, I would say, general question. I think you provide a very interesting mathematical tool to represent and manipulate, I mean, complex SDN networks. Do you have already some specific application or your tool on, I mean, for the use of SDN? What kind of application you may illustrate this on?
Okay. Well, as I told at the beginning, this is ongoing work. And we're actually working in doing this kind of things. So what we thought is you could use this in two different ways. Either an offline way, where you can represent your system and then do it to calculate what-if scenarios. You could calculate flows that go inter layers. So we can calculate all the flows, for instance, between the controller and the data device or applications. You could calculate distance between things. So this could be perhaps interesting for controller location, for calculations of where you should locate your controllers and this kind of stuff. Or you could implement this online. For instance, inside of a controller. And then you could calculate flows and also distance and whatever ongoing on the working system. And actually at this point we're working on implementing the algorithms to make this possible. But always based on a well-known and proven algorithm for directed graphs.
Wes Herdeker, not the JabberScribe, but USCISI. Would it be fair to say, because your conclusion, I think, was the same thing I was thinking all the way along, that this is really just another form of a directed graph where
yes,
you really aren't getting algorithmic benefits. It's really human visibility and human consumption of the data. So it's just another way to mark a directed graph with layers such that the human can understand it more than you're actually benefiting it from an algorithm point of view. Is that true? Doesn't make it invaluable, just
well, it makes it easier for you to model your system actually, because you can retain the idea of layers and vertices or locations differently, and also you can carry this information. So there are algorithms, as I told before, that uses the information that is inside of the composite vertex. So you can get result based on parts of the vertex, for instance. So it's not just the same as having the directed graph. It is the directed graph and has some additional information.
But yeah, so I guess what I was thinking in my head throughout your presentation, which is very good, I love seeing it, which is that it's really applying an additional attribute to edges and
yes,
vertices. And you know, you could apply 15 different attributes and still the algorithms would just make use of them generically, not because it's a layer specifically.
I'm Nmrg 3. My question is about the scope of your work. Data layer itself is multi-layer, including physical layer 0, 1, 2. Is do you consider that, or it's not? Doesn't matter of your work. Data layer itself is also multi-layered, right?
Yeah, you have multiple layers.
Yes.
Yeah, it's multiple layers. Yes.
Did you cover on that?
Yes.
Okay.
Okay, thank you. Let's move on to the next presentation.
Our next presentation will be from Michael on the Nmrg reference model.
No, this is okay. Yeah, is the wire is not long enough. It's okay. Okay, you can hear me? Good morning. So this is a brief presentation from the ANIMA reference model. We will go into more detail tomorrow during the ANIMA working group. Tomorrow morning is the ANIMA session. I'm giving a bit more background here in the Nmrg because we haven't had the background, so tomorrow's session is not going to be, tomorrow we have another session on the reference model, but that's not going to be the same thing, right? So it's a little bit more background here. So here's a high-level view. Who of you is roughly familiar with the ANIMA work? Anybody? A few? Okay. So in ANIMA autonomic networking, the idea is the devices do self-management. For that, one of the fundamental building blocks is that you do not actually push from a controller everything, but devices can figure out between themselves what they need to do. Think routing protocols. A router is being told, thou shalt route. I'm simplifying a little bit, but by and large, then it starts sending packets in all directions and sees the responses and says, I see this, I see that, and the other side computes a bit, gives, yeah, now I see that. And so they basically do just local interactions, and if you do this well, you get a consistent view of the entire network. The idea in ANIMA is do this with more than just routing, do this with everything. Right? And so what's really important is that the devices can see each other, the adjacent devices in particular, such that they can do such local negotiations. So what you see here in the reference model is blown up a device with its various bits. So obviously, if you want to talk device to device, you need to secure that communication. In routing, we missed that. We started without security and had to backpedal. Here we are trying to do it, build that in from the beginning. So we require each autonomic device to have a domain identification, a certificate essentially, because certificate is the only way you can do secure and scale. And so with the domain ID, a device can assert towards its neighbor, I'm router 17 at a certain network, AT&T.net, whatever. With that, you can secure all subsequent transactions. The question is, how do you get this domain ID there? And in ANIMA, we have a bootstrap draft that explains how you take a IETF ID, a preset device ID, which many devices have these days, a certificate that's made in by the vendor, put into the hardware, and how you can derive a domain ID from that. So here's the name of the draft that describes how that works. So once you have that, we bootstrap what we call the autonomic networking infrastructure. Backpedal a little bit. I said devices ought to discuss directly with the neighboring devices. The plane in which this negotiation happens, we call it the autonomic control plane. And what we do essentially is we hook up a secure tunnel, device to device, crypto tunnel, such that we don't have to, we envisage several different types of interactions, and we don't want to secure every single one of them separately. So we make one secure tunnel and we push all the autonomic traffic through this tunnel. Then security is taken care of. With that, you get an overlay network, and I'll explain that in a second. In this autonomic infrastructure, we therefore have a few things. We have the discovery to find, so that devices find each other. The ACP, the autonomic control plane, this is this overlay network that brings all the autonomic devices together in one plane so that they can discuss. The bootstrap I explained. GRASP is a protocol to do discovery and signaling and synchronization negotiation. So GRASP is also going to be used then on the layer above. What we're doing in the current variant of, the current version of ANIMA is everything up to the red line. So in particular, even though I said this is all about self-management, we're actually not doing this yet. Right? We are getting the infrastructure ready to later do self-management. So the self-management functions, we call those autonomic functions. And those utilize now the infrastructure that we bring up. The ACP is, as I said, an overlay network. It consists of these secure tunnels that go device to device. They are hooked up in a separate virtual context, VRF, on each device. So you essentially get a completely independent overlay network. Independent in particular of the data plane of the device of the network. It has no relationship because those tunnels are hooked up on linked local IPv6 addresses. So there's no addressing needed for this to happen. There's no routing needed for this to happen across the network. And now you launch those functions on the various devices. And so, for example, the bootstrap process itself is an autonomic function. That's the top line here. So for the bootstrap, we have a bootstrap pledge ASA, i.e. the device that wants to join the network. We have a bootstrap proxy ASA, which is here on the second device, and we have a registrar ASA. So basically a device talks to its neighbor. The neighbor acts as a proxy for the registrar. And so really the enrollment process is logically between the pledge, the new device, and the registrar. So you can see that as an autonomic function that sits on top of this autonomic infrastructure. You have a question, Shing? Okay. And so these autonomic functions can be instantiated, they can be preloaded on a device, they can be instantiated as needed. That should be modular, right? That's a big part. I think that's and so the draft names are all here on the site. So for the overview.
Yeah, that's not a question. That's the clarification from the Nmrg chair Shing here. Actually, for Nmrg working group, we charted for almost 2 years or 2.5 years. For now, we have 6 milestone work items. Reference module is one of them, which I would say one of the most important one. Besides GRASP, the basic signal protocol. The reference module, Michael has did a very great work. Also including some potential future work in this reference module described. Up to now, we are reached the point we almost finish our charter work item. That's including GRASP, Bootstrap, and ACP. Also the reference module and 2 validation use case. The red line there is in our current charter, but it's not necessary for the next charter. At least we know, even we may not go in too deep for each ASA, but we need to define the semantics for ASA or some option extension from within GRASP, so that the different devices knows they are talking about the same objectives, even they have different algorithm internally to decide what parameters or what kind of resource management they want to do. So this is something I'll encourage for people to make proposals for the future work. We probably will recharter the Nmrg working group the first half of next year after we finish those milestone work items. So that's a good time to make proposals.
And I would have called on Jefferson now. Good that you stand up yourself.
Yeah. No, I would like to say that remember the use case BOF of the Anima. There are several proposals on work for Anima, and as Michael said before, right now the working group is focused on the infrastructure for the autonomic functions. So I think that as Sheng said before, probably a good way to start with ideas for the future work are buffer, your use case buffer. There are several proposals considering that, and of course, and I think that tomorrow will be a moment to talk about that. There is all this intent discussion about how to do that considering Anima, and but just to mention that there are use cases that could be used in order to have different ideas. Laurent also has some interesting drafts on that. So I think we were plenty of possibilities to to go ahead considering Anima Charter.
And you didn't say what I thought you would say, so let me say it. Your presentation just now was essentially an ASA here, right? So the SLA monitoring that Jefferson presented earlier, that would be implemented as an ASA on top of the infrastructure.
And in our last review of revision of the draft, we did not consider that because it's kind of some time ago. But probably in the next draft review or revision or in a new draft, we probably are going to model our work as a ASA. So very interested in that.
Thanks. But so you see the idea here, right? The idea is that the idea is that everything below the red line is actually a generic infrastructure. Think IP. Simple, very simple, but very flexible communication infrastructure, automatically secured, self-creating, self-managing itself, right? And then on ASA, you can really focus on missions like tell my neighbor parameter A, and you decide what you want to tell. So all the logic is in the ASA, right? And that's the real cleverness then of autonomic networking. Thanks. So since we are in network management, this would not be complete without talking intent. We coined intent is now everywhere. It was our term at the beginning, right? We coined this term like 5 years ago. We said in an autonomic network, you specifically do not want to set every single parameter for everything. You want actually to have, by and large, devices figure out everything on their own. And now certain things you cannot figure out because they're policy. But that policy, we do not, if you talk today policy, many policies are essentially, again, a bunch of parameters, right? So what we did not want is specific parameters for specific devices. So when we coined the term of intent, what we meant really is a high-level policy, not specific for a particular device, maybe specific for a particular role of device, that yes. But intent does not let you say device A does this, device B does that, right? But an access device should do the following, and high level. And so this intent comes from a human. It is a policy. So this is a logically centralized function. That's the only, one of the few logically centralized functions in an autonomic network, which is otherwise a completely distributed model. But it clearly comes from a human, so it has to be ingested somewhere. So somebody thinks up this intent. We need a formalization of that. So it needs to be in something machine processable. That gets ingested at one point in the network. From there, the idea is, since we are not talking to a particular device as we do today with Netconf or anything else, everything is wrapped in one file. That file goes through the entire domain. It is flooded. So every device gets the same intent. And if we do this well, intent should actually not be not that big. So do not think like of all the devices, all the config lines. No, but hopefully not. Hopefully it's just a couple of lines. Things like this network offers guestnet services. That's intent. Forget about VLAN numbers and all this stuff, right? All that can be negotiated. We don't need that, right? But the fact that it should provision a guestnet overlay, yes, that is something that is a policy, right? So it gets flooded. It's the same file. And then every device, and we are just haggling about this in Anima, every device then takes the intent file, which contains the complete intent, and the current thinking is we split that into intents for particular autonomic functions, simply for practical reasons, because Jefferson will create his ASAs for the SLA checking, And so Jefferson will also be the guy who says, actually, the intent for this particular job should be ABC. And then we in the infrastructure, we don't care what Jefferson says. You wrap this nicely, give us a blob, and we pass this blob to the corresponding functions. So we split that out, and this way every device gets the part of intent that it needs. So I said everything in autonomic is about, well, not everything, but a large is about device-to-device communication, neighbor communication. In fact, we boiled it down to what we call the adjacency table. A device wakes up and it does discovery around it, and it will discover other devices. And it itself is in a particular state. The other devices are also in a particular state. So it will then see, for example, that one of the devices out there, this one up here, UDI, Unique Device Identifier 1, I don't go into the details, is already in a domain example.com. I myself am not in a domain. I just woke up for the very first time. I have never been configured. I have no idea what I should do. Current behavior is you try to see whether you should bootstrap to this domain. So you contact this as the bootstrap proxy and say, hey, I'm new here. Do you know what I should do? This example.com device will then contact the registrar. Remember from the previous slide, it goes to the central node for authentication and authorization. It says, is this one of our nodes? If so, shall we bring him into the network? And bring into the network means it gets a certificate, a domain ID. And all of this is registered here. So you may see devices from other domains. You may see other devices that have not registered yet. And depending what your state is and what the neighbor state is, that then triggers different actions. And so this is sort of the cornerstone of an autonomic device. That's what it sees. And depending what it sees, it does different things. And so where we are right now is formalizing a little bit in a state machine what an Anima device should do. And that is, we have more detailed diagrams. I have just picked out one for illustrating the concept. So an Anima device will first come in factory default settings. Factory default means it knows nothing where it should be. It has no configuration, no nothing. Then there is a bootstrapping process. And for that, I have a different slide, right? If you're interested, come tomorrow. There's a completely different state model, a slide that's fuller than this, that explains how the bootstrap process actually happens. The point is, at some point after that, it will be in the enrolled state. So state goes from factory default to enrolled. Enrolled means I have a certificate now. But it does not mean at this point that I have the autonomic control plane up to any of my neighbor devices. So that's the next step. So once I have my domain certificate, I will look at my adjacency table again. I will say I'm in domain example.com. Here's another device of example.com. And you start creating the autonomic control plane. So you negotiate, you authenticate the other device, you set up a secure tunnel, and so on. And all of that is yet another complete slide of state model to take the device from enrolled state to state in the ACP. Once we are in the ACP, I cannot yet be a bootstrap proxy because for that I need a registrar. The registrar is, think PKI, it's a registration authority essentially. Right? So you will actually look now via GRASP, which is our general discovery and negotiation protocol. You will look for a registrar inside the ACP. If you find one, you start the bootstrap proxy, and then you are in state proxy mode. So now, if this device sees other devices, it will invite them to join this domain. And so on. Right? Obviously, there's a respect for everything. It's not 100% complete, but I think you get the idea, right? And I think that's it. I think I don't have any other slide here.
Oh, okay.
So, any questions? Yes, Alex. Just shout.
You need to go to the mic because
okay.
there is.
clarification questions. Although I do understand the intent quite well, I'm just wondering how I would like to apply it in this context, bearing in mind that at the end of the day, if you dealt with a small number of intents, that's fine. But if you have millions or billions of intents to be handled and update all the time in a life cycle and a lifetime of a network, then the problem of managing this intent is more complex than actually what the intent want to do. And that's a chicken and egg situation for the last 50 years in policy systems. So how do you deal with this issue of scale, if you can explain it?
Right.
But the second issue is about the clarification for myself. I always liked the ANIMA model, and I understand it in some sense well, but I was wondering why some sort of orchestration of all these devices and systems, subsystems, are not part of a reference model, because at the end of the day, it's inconceivable to have all the things happening uniformly, and there will be some problems. So I was wondering where this orchestration, if any, is explicit here.
Yeah. Okay. Absolutely. So intent, first of all, your first point. Indeed, we are haggling about this in the ANIMA working group as well. And the question is, how often do we need to update that? Should we make intent more granular? Because, actually one slide down, sorry. My view for now is we flood this whole beast as a single file. Nothing pretty, very dumb, but very, very simple. And we get this discussion all the time. Is that granular enough? Here is my high-level statement. If intent really is a high-level policy, it's not going to change every 2 minutes. It's going to change every 2 weeks, if that. Right? If it is high-level, I think 2 weeks will be actually too frequent. Right? So I think even if this file is several megabytes, it doesn't matter. It happens once in a month. Right? And the mechanism to distribute it is extremely flexible. But we are haggling on that. We do not have the true answer. We do not know what people will really do. And I think the pragmatic view right now is, let's start with that, see what will happen, because frankly, we do not know what will happen when Jefferson actually puts his ASA out there. Right? Is he actually going to adhere to the idea of very high level, or are people trying to sneak config parameters in there? I can see people do that. Right? Route as intent, router 1 do this, router 2 do that. Ugh, yuck. It's going to happen though, right? So we'll see. And not satisfactory, but a pragmatic approach, shall we say. Okay. And your second question was, give me a keyword.
Why no orchestration?
Why no?
Orchestration.
Yes, there is orchestration. Effectively, in every network, there will be a level of orchestration. So this is not mutually exclusive to the SDN approach. In fact, it enables the SDN approach because, one slide up, please. Because today, if you have SDN in a large network, the thing that nobody in the SDN group is really talking about, because they have no answer, is how the hell does this device get to know the controller? And the nasty answer is, you have to go to every device and say, the controller is, and this is the secret with which you connect, and you do this on 20,000 devices and on IoT. Good luck. Right? So I think the truth will be a combination of the two. When you have the autonomic control plane and this capability under the red line, and I can demo that. I have a running demo. You actually have a network. You plug in all the devices and you power them up. And this autonomic control plane just starts building. It doesn't need a config. So you see, you see all the nodes popping up. With that, you have a security trust anchor. You have a PKI infrastructure that happens on its own. And you have a way to get to each device. And now it's really easy for an SDN controller actually to talk to any of those devices. So the truth is, this is absolutely complementary to what the guys in SDN are doing. And now, long term, I think there will be approaches that are more suitable for a central approach, where you have indeed a controller and where you push all the data down. There will always be things that work this way, but there will also be things that work better in a distributed way. routing, for example. Right? And so I think the truth will be somewhere, some middle ground, what you do distributed and whatnot. But with this, you have a way to do either. And strictly speaking, you could argue SDN is just a particular variant of this, where you have one big ASA that you call controller, and the other ones ASAs that are basically the netconf resconf interface, if you want. Any other question?
I think we have to move on.
Yeah. Thanks, Michael. Our next speaker will be Alex on the slice networking and management, research challenges and trends.
Thank you. I hope that I remember the sequence of the slides. Yes, good morning, everybody. Again, my name is Alex Gales. With two colleagues from Hawaii, we produced a little document to start a process by which 5G management could be put back in a center of the research here at IETF. And that's the purpose of my presentation, which is much more than the document produced for ANIMA, which will be discussed later on. Therefore, the main issue here is that we are facing quite a long and important area called 5G management, which becomes essential for the wire and wireless networks of today. And part of it is a way in which we group different entities together in order to better manage them at the end of the day, rather than anything else. Although it is conceivable to use node management, but this does not easily help. And my presentation will just produce a set of questions. Currently, there are no solutions, but I will also motivate the importance of this question in the context of 5G management. I will start by saying that I was quite impressed by the fact that one of the gaps analysis in the management working group states that actually it's a time to move towards what is called managing resource relevant configuration, not only resources. And that's an important message here. The resources are many. However, if you combine them and group them and you manage the configuration, it's probably more profitable than actually doing it directly on the resources, although this could be done and should be done. In the past, this issue of grouping resources, in particular physical resources, was evaluated more than 15 years ago in the research done for active networks, as well as research done for distributed testbeds. And it continued to do so. It evolved towards grouping not only the resources and manage them accordingly, but also the logical resources and later on virtual resources. And some of these definitions which are appearing here and are related to the fact that the concept what was created as slice. At the beginning, a slice was just a simple grouping of resources which have a capability to be managed as ones. Next, please. But that concept evolved to much more than just a grouping of resources. It evolved now towards as additional, if you want, as a container for running application and services, but also as an aggregator of all the elements to characterize and bring together the facilities for running customized services. And this is a current view, and to my knowledge, in all the standard groups, this concept, much more than grouping of resources, of networking slices, is now at the center. And all the research projects which I'm aware of in in 5G management have that as a heart. And although the definition is not acceptable yet in a sense that being uniform, but it's emerging as being a unifying way to handle different type of groupings of resources. On this slide, you have maybe other definition from the past, but next one, please. They evolved a bit further, more or less, as I said, towards not only groupings physical, logical, and virtual resources of the network, adding the service resources which are mappable to this container, plus the network functions, some virtualized, which are part of the same containers. And as a group, suddenly, it's much more than a simple overlay. Many bear in mind that this concept of network slices could be a crossover network, concatenating different slices and brings them together, but also could be seen vertically in terms of concatenating at a different level of data plane, control plane, management plane, and service plane, different other functions, which could be more applicable for IoT management. So suddenly it's not only just a network-wide concatenation of resources. Next one. Obviously in 5G wireless area, this is also taken seriously. And this is one example of representing, if you want, the same concept in the radio, if you want, access part of the 5G. However, next. This concept, which is now established, in my view, and it's roughly accepted by all the operators, to my knowledge, and to my knowledge also by all the other players to be dealt with, because there are examples, prototypes, open source even, solutions for making network slices, brings me to define a bit what are the key characteristics which are very useful in this new problematics. And I selected 4 or 5, which I'm going to share with you, which I believe that they will be motivating if you want some additional work which is needed for management in this context. And they are listed in no particular order. One is the fact that it helps concurrent deployment of multiple logical and independent share or partition networks in a common infrastructure platform. And this is quite essential. If you don't have this concept in place, then you have to organize your, if you want, share platform by hand all the time you want to do it. And that's not practical, it's not scalable, and it's not very useful. So if you have it, it will help this essential element. Second, it helps a separation of different things related to provision of services, management of service per groups, as well as integration and operational challenges for different parts of the communication needs.
Sorry to
without
interrupt.
moving.
The Jabber scribe just lost his power, so if somebody else wants to take over, that would be helpful.
But there is a power connector if you want.
I don't have an adapter.
I'm sorry. Okay. Now, one additional element which is important is that this concept supports multiple multi-service models to be put into place. Given the fact that services are quite complex these days and they need models to attach it. And they are not anymore totally decoupled from the network infrastructure. So that's quite an essential element, and it's a usable element. And actually it's one which probably, in my view, the operator likes most, because in this way, if you have different slices, on each slice you can provide or provision separate services with different qualities, where management is done differently. Next one, please. There are a number of ways to exploit this concept, in particular by the operators. And two elements are important. One is because at the end of the day, this is like an abstraction. It allows a simplification of the operation, namely provisioning, which costs now more than in the past, but also provide new services, which is the main activity of the operators. And to some extent, if introduced well, in a consistent way, in particular on the wireline networks, it will help change a bit, moving from a node-based centered management activities towards a grouping of different kind of things, which will make it easier to implement autonomic functions. Although I understand that it's very easy to say, okay, every device will be autonomic, this in practical terms is impossible, because you cannot make all the nodes on this planet autonomic, because it costs too much. And to do it, maybe there is a middle way to do it, is apply it to the slice controllers, if you want, only. Yes? Thank you. Next, please. Now, the scenarios where this concept could be used with profitable ends in terms of managing the networks are listed here, but in no particular order. They could be used for mission-critical type of communication services, for different type of services related to massive connectivity. Also, it also could be used for enhancing or putting more controls, extreme quality of service or extreme SLAs if needed, not across the whole network, but in one part, and leaving more loosely defined and loosely controlled SLA in other parts if needed. It will enable to have some independent autonomic management functionality applied to different partitions as the end of the network, not one for all. And I think that's a practical way forward. And it could help also to understand that in this way you can create what is called independent multi-topology routing, which all the things which are implied by this statement could be made practical, because you do it per groups. And at the end of the day, it's another way to share the infrastructure with a view to manage it well and with a view to deploy services, which is basically the driver for networks these days, as far as I understand. Next, please. Now, in the little document which was produced by the group to be defined is a suggestion about how to define this network slicing. And this is one example, one initial example, which hopefully unify everything, which is proposed even for standardization. Sooner or later, this has to be done, bearing in mind that network slices produced by one party may not be the same like the other party if the semantic is not the same. Therefore, as a result, you cannot compose similar slices in a bigger entities. You cannot decompose them. You cannot manage them uniformly. And you cannot take advantage of them properly. So a definition counts quite well, and it's clearly needed. And the suggestion, it is just a suggestion, that network slices include basically 4 elements, not 3, not 2, not 1. All of them, otherwise will have a different type of concept. One is the fact that it includes grouping of service instances and components. The second element are the network functions which are linked to this container, the resources, physical, logical, and virtual, related to this container, and more importantly, and now this is quite a suggestion, different one compared with anything else, is that it has to be managed uniformly in what is called here capability exposure. Bearing in mind that not everything underneath a slice could be made public for other systems to use. Maybe the operator would like to restrict some of the capabilities. So this restriction or this control should be made customizable. But in addition, the exposure, capillary exposure of the slice means also that it could be used by other systems, management systems, other service systems, and so forth. And that's a proposal to unify a bit and move forward. Next, please. Obviously, this concept has a lot of work to do and is based on requirements captured through different means, mainly related to how this applies to 5G management. And this is quite a long list, but a relatively high level of requirements needed to put this concept right. One of the key elements is the fact that this is programmable in a sense that it allows in a flexible way to do either through APIs or other models, change the system. If this is not available, then it's obviously it will end up later on in 5G management as they need to be changed after 5-6 years. So we need programmability at the heart of this concept and the system. Next, please. Now, I took the view that this new container called service or network slicing adds value in management, and I'm suggesting 3 examples where this could be added explicitly to do it. One in the context of Anima, and this picture is more or less showing that the network slices and the slice capillary exposures and the autonomic orchestration of them are, if you want, part of the Anima, should be part of Anima model, as an example. It's exactly where the red line of the previous presentation is. It's not just a line, it's a concept to allow this to be moved forward. This is a way to handle still autonomic functionality based on slices, not directly on the devices. Second, please, is the fact that this new concept in this area could add value to make SDN deployable at large. You can wonder why after 8 or 9 years of SDN and prior SDN versions, which are programmable networks and many other forms of programmability which appeared, why they are not deployed at large? One of the problems is that you cannot change all the nodes on this planet. So there is clearly a need to understand how to still use the SDN principles to apply it. My suggestion is you can apply it not only to nodes which will handle flows, but also to network slices. Because that's an additional element which will help, in my view, SDN deployability at large. Next, please. The same applies to the NFV model, which is also generated recently in ETSI, which it could be also applied to the fact that you don't deal with hardware resources directly, but with this higher level abstraction, which is network slices, and to help the network function virtualization to be put in place, because it is not in place yet. And these 3 examples shows that there are a lot of commonality, and maybe it's a way to bring them together. It's not good enough for me to that one group to talk about NAV, another about SDN, and another one Anima. It's a time to understand how you can take advantage of all of them, but to bring it. And it looks to me that this concept, which is network slices, it's not only helpful for the operators in the context of 5G, but it's also helpful to bring this community forward. Now, the question is, what are the new problems to be handled, please? And I have a list of around 10 questions or problems to be solved. So that's basically the main output of my presentation. before running, we need to understand how to walk and to solve some of the network slicing management problems. All of them are nearly management problems. And they are in no particular order of importance. Probably some of them could be done first, but in principle, they end up with they need to be covered, all of them, gradually. And maybe this is a suggestion for working items in the future for this working group as well as others in IETF. It's one of the issues about the terminology, but very important is the reference models, which could take advantage of this new container, which by definition is a container which is a grouping of resources, but is much more than a grouping. It's becoming like an abstraction on which you apply the management function, autonomic functions, as well as service functions. The important points are about slice lifecycle management and the way in which protections are created and isolation is created within the slice. As I said, a network slice could include different vertical functionality from not only the data plane, but also control, management, and service planes. And you select a subset. And once you do that, you have one slice which may be applicable and usable in a context of IoT ecosystems. And the issue is, if you have another one, are they having some elements in common or not? You have to ensure this for the lifecycle management becomes essential to put this in place. There are still prototypes available, but this is quite an important problem to solve before you start to use this concept in anger. It's also important to see that there is no need to drastically change the whole management approaches to networks, and it has to be done with without re-engineering the infrastructure, because this is not needed. Now, fortunately, this high-level construct, which is in between the node and the overall network, and it's constructed especially to have a management, and in particular, and service focus, helps that process. Next. There are a number of other problems related to it, and I will not read them all. One of the interesting points is about orchestration of slices. It becomes a separate topic compared with service orchestration, resource orchestration, or network orchestration, which is now becoming an issue. Next. So the purpose of my presentation was to highlight maybe one of the important elements in 5G emerging management, which is network slice management overall, as an important topic for research and some of the developments which are applicable, and the need to look at this holistically rather than to, if you want to look at from one angle or another one. That concludes my simple presentation for the future. Maybe in 5 years, we'll have a retrospective and have a proper review of what happened. Thank you.
Thank you. Questions?
Very quickly, please, because we are already behind schedule. Thank you.
Yeah, Julien Maisonneuve from Nokia. I took a good look at your presentation, so I must admit that I don't know a lot about autonomic and what you're doing, well, the specifics of it. The concern I have is that I took a look at a large number of European projects that deal with slicing, and the problem is that many of them introduce, like you do, slicing as a first order object, and that it becomes a construct in its own, which has its own reference points, its own components. And up to now, I haven't seen any use case that really justifies adding a new layer, adding new components that way. Because when you think about it, slicing, if you see it in the same grouping as network service, then you do realize that once you have defined a network service, you can actually group the slice as a given network service. That is, whenever you define that network service, you don't need to see what is outside, you don't need exposure, and it creates de facto a slide for this given network service. And so I don't see what real use cases really require that we expose the slice beyond the definition of a network service at this point. And I mean, when I mean network service, I mean on a higher level, at the OSS level, for example.
You may be right or wrong, I don't know. Or I may be right or wrong, but at the end of the day, if this is a practical, useful way to move forward beyond this, apply all management facility to the whole network, I think that it's should be looked at seriously. If at the end of the day we have only very few slices, maybe tens, hundreds, maybe not millions, in a network, produced dynamically for a purpose of deploying separate services, and this is useful for operators, then it will be the norm rather than exception. And this is the real question: how many slices can you handle realistically into a network? And this is an open question. My understanding is that at this stage, use cases are very useful to produce requirements for such as things, but they are not the only driver for this concept to be taken seriously. Bearing in mind that actually it's happening across now many other groups, not only research projects in Europe, but also research projects across the world, plus all the other standard groups, which are ITUT, IMT 2020, which is basically the one dealing with this subject in ITUT, but also in 3GPP. And the issue is, when you want to handle this management, and this is a concept in my view, which is centered around managing this construct, is not only, that's the center of and focus of this. It should be also looked at in IETF terms, if that's possible. Is that always work driven by use cases? No. Bearing in mind that use cases are very good for functional description of the things, but they are useless as far as the non-functional elements, as far as I understand. So as soon as you take the non-functional requirements into account, namely performance, scalability, manageability, usability, transformability, elasticity, and all this, suddenly use cases are not so useful. If this concept is useful for operator, so be it. And it looks like it is emerging as an important thing, which is not replaced by something else. So why not to do it? It has work was done in the past in terms of research work in a precursor of SDN, which is program networks, active networks, dealing with this concept. There are some examples and still lessons to be learned. Definitely in terms of management and management functions, it looks to me that it has to be looked at in a bigger context, and that's the context which I'm suggesting.
Yeah, and I think there is no dispute that slices are important and useful.
Yeah.
It's just that the level at which you want to expose them might differ. So the only experience I can report that it was a project in the European Union called Norma, in which there were 3 types of orchestrators in the same architecture. You had a slice orchestrator, you had an NAV orchestrator, and you had the MEC orchestrator at the same time. And it's becoming very hard to actually make sense out of what orchestration means at that level.
I do understand you very well. Bear in mind that I do understand very well the Norma project, but I am also aware of other projects that have 4 orchestrators, and suddenly the question is, what is orchestration? I made my own list of suggesting that there is a major difference between orchestration function vis-a-vis of management functions, and my list of orchestration functions are around 100, and all of them dealing with coordination of activities. All the other parts related to operational part are in the management, which are maybe 1,000 functions. How to orchestrate well all the parts at the level of resources, maybe slice, as I suggested, also at the level of services and networks, it is an open question, but it's an important question to answer. And maybe Norma examples and others will help to understand how to create the granularity in orchestration and how to use it to the purpose of a better system overall. So that's the answer, or at least the beginning of an answer.
Thank you, Alex. Thanks for the interesting discussion. I think you can bring it also offline on the list or through corridor discussion.
Just an announcement. Today at 7 o'clock in studio number 3, there will be a further discussion about slicing. If you want to participate, you're also welcome. Thank you.
Thanks. Our next speaker is Will on the super policy-based management framework.
No, it's the old one. Actually, updated a couple of slides, so better if you can please put that on. Let me check.
Okay, we try to do.
Hello, everyone. This is Will from Huawei. Today, I was invited by Lauren to do a presentation about the SUPA framework. So before the slides is prepared, I would like to share a little story. Last week, I was in US. I'm not there voting for the president, but instead I was attending a conference called MEF. In that conference, I was talking with a CTO from a big operator from the North America. And we are talking about the complex human configuration and management of network. He shared a little story, is that he said, just think about our children, our kids, next generation. When they were born, they are using iPhone, iPad, automobiles, such as even the self-driving cars. So they are using everything automatically intelligent. So how could you imagine that after 10 years or 20 years, when they grow up, became a telecommunication engineer, they can configure the network service management with tens, hundreds, thousands of commands. How do you think of that? So he thought the revolution of the network management will become, sooner or later. Just look at the automobile. How many intelligent, automatically devices, little blocks are there? You can even without press the accelerator on the highway nowadays, right? So I'm here to talk a little about the policy. We actually started this work since 2014 because at that moment we think it's the right time to do the evolution, a little bit by little, since we are in IETF, so we need to bottom up. So after a lot of times, modification of the charter, we have the SUPA working group founded in last year. And I'm the author of this framework. We have also other co-authors from China Telecom, Netcracker, and Tsinghua University. So just a little more about SUPA is the full name is simplified use of policy abstraction. So I don't know how many of you know this working group or read this draft. Could you please raise your hand? Oh, thank you. Next slide, please. So this is a little bit about the policy. Actually, maybe 10 years or even more ago, there are some discussions in IETF about policy. But later, when this new trend of SDN, grow up, we restart to discuss this term in IETF. So we need actually an accurate definition of what is policy in the terms of IETF context. So here we have it's a set of rules that define how services are designed, delivered, and operated within an operator's networking environment. This is from the SUPA charter. And we need a model to be the carrier of this set of rules. And we categorized these rules into two types. One is imperative, or in other words, it's ECA, it's event condition action. And another way is declarative. And often people call it intent-based or goal-like. So this working group, as I said, is formed in last year, October. The goal of this working group is to define a data model to be used to represent high level, possibly network-wide. So it's very abstracted way of doing it, which can be input to. Please note that here we don't, specifically write it as a specific device, but we wrote it like it can be within a controller or orchestrator or even a more intelligent network elements. So this kind of managing the function. Next, please. And well, this is a little bit background about this draft. Due to time limit, I will not go deep in it. Just our working group have 4 deliverables. We have on the top, you can see a figure. We have an information model and a data model and this framework and also applicability document. So these are 4 documents. I welcome you to join our discussions and contribute. And this draft has a long story. I will not go through by it. And our draft was adopted by working group at August this year. And now it's still under updating, and welcome to give us more comments. So next, please. At this slide, I guess some of you might be a little unclear about the difference between the 2 kinds of policy. Sorry. So I will use these slides to briefly discuss the difference and how to define which policy it is. So on the top, you can see these are our deliverables. So just like what I said in last slide, we have 4 deliverables in our charter, but we also have a dashed one. It's a declarative or intent data model, which is not in our scope. Because at that moment, AD still think it's a little bit for future work. So he said, this is not being our scope now. However, work on this can be a recharter work for Super. So here I need to talk a little bit more about this difference. So for the imperative, or we can call it the ECA policy, you can see it's a very it can simply be said like it's like the event. If the event is true, and if it meets some sort of conditions, and then the network device or the functions can execute the action. So in here you can see the policy will explicitly, express the details. How should the network do to behave according to these predefined rules? But in other way, the declarative, or we can see the intent, here is a famous examples. Maybe most of you have already know it, is that if I want to go from one place to another place and I have the budget, I don't care how can I get there, but with this budget, as long as I can get there, it's okay. So in this way of pressing, you can see it's a more abstracted. You need a more intelligent management devices system to do it. So it only express the goal, or in other words, express the ideal state you want to meet without telling the network how to do it. So I guess there are many kind of definitions of this, but we have we choose 2 here. It's a little bit small here. So in Super Charter, we said declarative policies specify the goals to achieve, but not how to achieve these goals. And in the ODL NIC project, it's also a project discussing about the intent. It said it provides a generalized and abstracted policy semantics instead of open flow-like flow rules. So next, please. And this figure is from our draft. In next 3 slides, I will use 3 figures to describe the the process and the architecture and the relationship in our draft. So here, the first one is the process of the generation of a policy. Actually, if you look at it from the top, we have IETF there to define and to assign and manage the content of this policy. To be noted that we have this short form, the GPRM. It means the generic policy information model, and this EPRM is ECA policy rules information model. So basically, here we have those 2 information models, the GPRM and EPRM, defined on the top, and which can define the concept of policy of data models. So here we first have the information model, then generate the data model accordingly. And then these policy data models could be generic, or the ECA policy young data models can be cooperate with the resource and the service young data models generated by other working groups from the IETF or even other SDOs. These two way combine together to work on this service interface logic. And then the operator can fill forms and run the scripts, and they basically do the, interact with this interface logic. Then finally generate the configuration snippet to the local devices. Next, please. And this figure shows you about the architecture way of look like. So here is where the policy will be based. We have drawn on the top, there is OS, SPSS, or orchestrator. And then we have this policy rule, super policy model. Inside we have information model, such as GPRM and the EPRM. And then this can derive to generic policy data model and the ECA policy rule data model. And this can be communicated to the network controller, EMS, NMS, and even, in some cases, maybe the network element, just like in previous slides said. So this figure is still under discussion and updating. Actually, I received some comments this morning from my other co-authors. So we will modify it accordingly. So welcome to review it and give us your comments. Next, please. And because when we are talking about policy for a while, people came to us and asked, what is the relationship between this one and the service and even the resource? So too many people come up to us, and then I draw this figure finally in our draft. So we can illustrate the relationship between the policy, service, and resource. So here we have a policy on the right. And in IETF, we have super working group. And the service, nowadays, we have L3SM. It's a layer 3 VPN service modeling. And also, we have recently created a working group called L2SM, which is for layer 2 VPN. And for the resource, we have many drafts in different working groups in IETF. For example, inventory, topologies, blah, blah. So here we have 3 kind of relationships among these 3 triangle. So first, from policy to service, we can see that policy manages and can adjust the service behavior necessary. And here we have a 1-to-1 or even 1-to-n multiple relationship. For example, you can use one piece of policy to adjust to manage multiple services. And also, it has the same relationship with the resource. It's policy manages and can adjust the resource behavior as necessary. It's also a 1-to-1 or even 1-to-n relationship. We have some use cases for that. And the final one is actually it's not in the scope of SUPA, but we also draw it is the resource host as service, and the changing resources may change service behavior as necessary. So next, please. And until now, we have got some reviews, and we have received comments online and offline. Most of are listed here, and we have addressed most of them, and are still discussing with the one who gave the comments for some of the particular questions. And next step, we will submit a new version with about comments addressed. Next, please. So that's it. Hope you can be interested in our work and give your comments. Thank you for your interest and welcome to contribution. Thanks. Any questions?
Okay, I think we may not have time to have questions because we're a bit late, but the idea of inviting also a reference model from Anima and the policy framework from SUPA was to see if there are any cross-working group or research group interests from the management point of view. So I think we may have follow-ups on the mailing list or even through discussion at this meeting about what needs to be done or what could be done from the management point of view for policy and autonomic networking. So thank you, Will, for accepting this presentation. We have now a few set of slides we would like to go through rapidly and get the feedback from the group on the situation of the Nmrg and maybe possible actions for the future. So we had two active ID in the group. So one which is has been presented today by Jefferson on the SLA violation detection, and there was this call for a research group last call, which we think is ready. We will forward it to the list in order to make formal call for the research group last call and proceed with that. Jefferson?
Just to add up in the mix, there are another draft from Costas Petikosis. It's autonomic networking definitions revisited, and the Costas was the leading author of this draft. And then I'll talk to him at Yokohama about this draft. And after that, he changed his job for another organization, and he said that he was not able to continue the work on the draft, but I am interested in continue it. So maybe it can be another draft to keep up in the Nmrg if there is interest in the group.
The fact that that draft has expired, we need a new version of it submitted and so on in order to move on with the discussions. Before that, it's not possible to do anything with that.
Yeah. Costas, I talked with Costas, and he agreed to pass me the token in order to revive the draft. So.
Yeah, okay. I think for me, this is also part of the future items where we maybe have some specific topics. The second draft is Nmrg location IP fix. This has already passed the IRSG review and was okay to proceed, but there was a question raised if this document belongs more to the IETF or IETF. So we have also liaised with the Ops Area Working Group, where this draft has been announced on the mailing list to get feedback from IPFIX expert, because the IPFIX working group has closed, in order to get a bit more feedback on where we should post this future RFC. So we are still in progress. We need to meet with the Ops Area Working Group chairs in the coming days to state it also on this aspect. But this is quite advanced, and we will statute very soon on the future of this draft. So a bit of overview of what has been done quite recently on the group. So we had several initiatives to make joint meetings with, for instance, NFV and SDN research groups in Berlin on the management of virtualized and programmable network. This was quite successful in terms of presentation attendance. We had a bit of more difficulty to exploit the outcome of this meeting, but we are still working with the other chairs to see what could be future actions for that. We have also some regular meetings and workshops, like we had one on Sunday on managing Network of Things, trying to also outreach towards the Things-to-Things research group or other research groups on new areas of applying management from the Nmrg point of view. We had also in Berlin a specific meeting on the flow measurement people that was quite successful, and we had also tried to maintain what we call interim regular meetings, means not located with IETF meetings, usually one per year. The last one was during the NOMS conference in Istanbul in April this year, which have some topics around intent-based networking. And the next one is planned to occur in with the IM, Integrated Network Management Conference in 2017. It's May this year in Portugal, Lisbon. So now the most important part is for the future of this research group. So we have discussed with Lisandro and some of the folks working in the group what would be some possible future path. What we feel is just open thoughts, and we really get the feedback from the group live and on the list is we have seen that concentrating maybe on specific issues, specific topics will be a way forward. We had in the past some dedicated teams that seems to work well. One example was the series on autonomic networking a few years ago that led to the UCAN both and then the creation of Anima working group. So we have this legacy, and we have seen today that there are still some topics in the area of autonomic networking that could be worked together between Nmrg and some other working groups in the IETF. There is the series on flow-based network measurement, which has a good active community and some regular workshops organized on that. So this is, I think, a good active groups in this Nmrg. We had some joint meetings with other research groups and also things to things. Overall, this make good or better attendance in the meetings. We have quite active sessions, good presentation, but the return in terms of really documentation, I will say, is quite low. As we have seen, we have only 2 active internet drafts in the group. So this is not the only metrics for a research group, but at least except for the meetings and activity in terms of presentation and reaching out to other groups, it's a bit difficult from our point of view and also from the IETF chair point of view to measure, I will say, the progress of the research group or the production, if we need to talk this way, coming out of this good level of activity we have in the meeting. So this is for us an open question, how we can maybe have a bit more of documentation produced by the groups, either through reports, IDs, whatever forms that may be suitable for the research group. So now it's a bit questions to the room, question to the group. What will be your feeling about approaches for the future of Nmrg, ways of working, ways of documenting the work? So it's up to you, please. Don't be shy. Huh? It's your group. We are only here as convener. Any ideas? Do you share, a bit this aspect of going towards dedicated topics? Or is it something you don't want to consider?
So what's your plan for the next research group of meeting with, looking on the academic conferences?
Okay. Yeah. So your question, Will, was?
The plan for next research group conference. Not during the IETF week, but in other.
Yeah, so the next non-IETF located Nmrg meeting will be in IM conference, Integrated Network Management, IM 2017 in May in Lisbon. The call for paper is still on, I think, and there are some workshops organized there. What we think as some potential topics also for future activity is around management in the scope of 5G networks. Also consider a bit of cross aspect around NFV and NSDN management. There are ongoing work in both of these urges about management aspects, but those are drafts that are stamped as SDN or NFV. We tried also to see if there are some joint work we can organize with them. A new area we could investigate also is management aspects or operational aspects with respect to IoT. So there is the things to things research group, which is very active. We need to see if we can also work with them on more management-oriented aspects. Another topic which is a bit transverse to that is the aspect of visualization and user interfaces. How, work we can do in this area and what we could benefit for the community on those aspects. And also the fact that we try to approach cross-disciplinary topics from the network management point of view. And the key issue is how to effectively and efficiently bridge the different communities, as for example, the visualization and user interface communities are quite different from the network management community. So if we go to conferences on those topics, how to approach them with joint workshops or and vice versa, invite them to Nmrg meetings. Again, your view are very welcome on these proposals.
Just let me mention about the fact that this plan to have an interim meeting together with the IM and OMS conference. The idea is that the core of the network management, let's say academic communities tend to attend this conference. So the fact that the meeting will be there, potentially will have more participation for them. But as mentioned before, it doesn't mean that we will have additional IDs, for example. So it's a challenge itself in order to have these works transform into output of this research group.
You asked for a suggestion how to increase the productivity. Obviously, collocating IETF with other academic-related events will help, but as you said, may not automatically lead to more productive and more documents. Maybe one way to go about it is to request in these academic-related conferences, which are established for a long period, to have a separate track, if you want, dedicated to standard-related research. The call for papers will attract hopefully significant numbers, and some will be selected and published. But once they're published as part of the conference, to have some automatic, nearly automatic link to create a report or a document which has an IETF working group stamp automatically, with a bit of help. And in this way, you'll be able to collect more and a wider and ready-made, let's say here, output. That goes a bit against what IETF does. It's centered around the IETF, but may help. Now, if it's organized well, you increase from 2 to maybe to 20 million documents per year. Maybe not have the same input, the same values, the same impact, but at least there could be one way forward. And also attract more researchers to this IETF, let's say, ecosystem. Which the problem is that, as I understand it, because I'm here, it's quite difficult to reach a point where you have a footprint. For researchers, this is important, to have somewhere at one point to have a footprint. And 1 or 2 drafts are not sufficient for bringing a bigger audience. So it's something which could be added easily and part of the process. The other thing is that this sort of reports should highlight not only frameworks and terminology, which is mainly the subject of all these drafts, but also some specific solution in cases, and maybe link it with a bigger reference configuration of models at a later stage. That's my suggestion.
Thank you, Alex. Thank you, and I think we will also provide these questions and expect your comment on the mailing list. I think we have to close because other people would like to use the room. So thank you for your attendance. Please bring back the blue sheets to the desk, and see you very soon. Thank you.
Thank you. Hello, sorry for that.
1:15. So we can convert some.
Yeah, it's okay. So here, it's the
yeah, that's it. What does it mean?
Nmrg.
Network management.
How Nmrg? Nmrg. You got the like.
We thought you were coming.
Yeah.
We talked a lot about 5G.
Yeah. There's some overlap, right?
Yeah, for sure.